now start our discussion over today. All right. So can you guys see my screen now?
Yes, sir.
All right. So before we start, just would like to see that this topic is not really part of your midterms anymore. Okay. Your midterm topics are from the start chapter 1 to chapter 3 only. These clippers is topic from the finals. So we'll be discussing it now because we still have 3 meetings left and then we have finished the topics very early. So we'll take advantage of those 3 meetings for us to be able to take as many topics as we can so that we can have a lot of free time during the finals. Okay, so suffer now, enjoy later. Okay, that's a better idea when it comes to dealing with problems. Okay, so just to be clear, the coverage of your midterm exam next week will be from chapter 1 to chapter 3 only. All right? So chapter 4 onwards will be for the finals. Okay? So I hope you guys are there so that you won't be rushing in uh, reviewing from chapter 1 to chapter 4 or chapter 1 to chapter 5. If ever we'll be able to finish this one, of course, we'll go with chapter 5 next meeting. So again, midterm exam will be from chapter 1 to chapter 3 only. Okay? So are
Okay,
you
sir.
all right? So are you guys ready now?
Yes, sir.
All right. Okay, so the first thing that you need to know is what is clippers. Okay. So it is actually very straightforward, okay? Nothing fancy or nothing tricky. When you say clippers, it clips or it limits or it remove or it prevents, okay? So any of those definition. Some portion of the waveform. So what is that waveform? It is the input signal. It could be from above or below a certain level. So one very good example of this one is the topic that we've discussed last meeting, the half-wave rectifier. Okay, so in half-wave rectifier, so it could be a waveform from the top only or from the bottom only. Okay, so if we have a waveform from the top only, then it means that it clipped or the bottom portion was clipped or was limited or was removed or was prevented. So any of those uh, definition. So vice versa, if we have a waveform on the bottom, then the upper portion was being clipped or was being removed. Okay. So in other words, clippers are a circuit which limits positive or negative amplitude or both is called chipping circuit. Okay. So we have already done this one last meeting, limiting the positive part or the negative part. But in clippers, it's also possible that we can limit both of those sides, the positive side and then the negative side. Okay. All right. So first, you need to know what are the types of clippers. Okay. So we have the series positive clipper, which is that clips the positive side, which only shows the negative side. Okay. And then series negative clipper is the opposite of that one, of course. So negative clipper clips the negative. It removes the negative. Okay. And then number 3 is shunt or parallel clipper. So mostly they call this one shunt clipper. But in layman's term, this one is just a parallel clipper. Okay. So shunt or parallel clipper is the opposite of this one, of course. Okay. So if we have a voltage or a forward bias, then that's the only time that it will conduct a voltage output, or vice versa. If it's uh, a forward, did I say it right? If it's reverse bias, that's the time that it will conduct. Okay. If it's forward bias, that's the time that it will not conduct current. So I will uh, let you know why is that opposite when it comes to series clipper. Okay. So it has special case actually. And then of course, the fourth one is shunt or parallel positive negative. So this one is just non-bias. Okay, but for this one, it is now being applied with bias. Okay, shunt or parallel positive with bias or negative with bias. So I will let you know what are those bias that I'm talking right now. And then the last one is of course the capability to clip both sides. Okay, could be the negative or the positive. Okay, so first and foremost, series positive clipper. So from the word itself, it is clipping the positive side. Okay, so in a series positive clipper, a diode is connected in series with the output as shown in the figure on the right side. Okay, so during the positive half of the input voltage, the terminal A is positive with respect to B. So this reverse biases the diode and it acts as an open switch. So therefore, all the applied voltage drops across the diode and none across a resistor. As a result, there is no output voltage during the positive half cycle of the input voltage. So the same with what we discussed last meeting. So same concept, same idea. So in here, as you can see, we have you know the cathode and then the anode. And then if we have here the positive cycle, then this will make it a reverse bias. Am I right?
Yes.
So if this one is connected to this cathode or this N type is connected to power supply, and then this anode or P type is connected to our ground, what will happen? What will happen to our diode?
So it will be reverse biased.
This one will become a reverse bias. So in other words, if this one is in reverse bias, then it will not allow to pass through a current, right?
Yeah.
So as a result, in positive cycle, as you can see right here, okay, there is no current, zero. Okay, so the only time that this will conduct is if the N type is connected to the negative side, and then the P type is connected to the positive side of the power supply. Okay, so series positive clipper clips the positive side, right? So that's the idea behind the series positive clipper. So as you can see right here, the naming itself, indicates that it is clipping this part. So series positive clipper, it is clipping the positive side. Series negative clipper, it is clipping the negative side. And then for the shunt or parallel, so this one is same concept. So if it's shunt positive parallel, then it's clipping the positive side. Or if it's shunt or negative parallel, then it's clipping the negative side. Then of course for the last one, for the number 5, it clips both the positive and then the negative, or it limits, okay, the positive and negative. All right. So next one with this one. All right. So I think we have already discussed this one. Okay, so I've just actually completed the this one, the description or definition on what will happen if it's on the positive side or if it's on the uh, negative half. Okay, so this one is the explanation for the positive half, and then this one is the explanation for the negative half. Okay, so same idea with the last meeting for the half wave rectifier. Okay, so again, clippers prevent either or both polarities of a waveform exceeding specific amplitude level. So however, a positive clipper is that which removes or clips positive half completely. Hence, the circuit of the figure on the right is called a positive clipper. So here it may be noted that diode acts series switch between the source and load. Due to this reason, the circuit is called series positive clipper. Okay, so that's the idea behind on why we call it a series positive clipper. Okay, so here's like the summary when it comes to series positive clipper, and then the formula that you're going to use if we are in a positive half cycle or if we are in negative half cycle. Okay, so this one is strictly for series positive clipper only. Okay, so for series positive clipper during the positive half cycle, so of course our V sub O is 0 volts since it will not allow a voltage since it will be in reverse bias. And then for the negative half cycle, it will allow now the current to pass through to that diode. So we now have a voltage output wherein you will get that one from our V sub I or the voltage input and then the voltage threshold. Okay. So those are the things that you need to consider. Okay. So if you have here a bias voltage. So you have to add here Vi plus B sub D plus B sub B. So now you're dealing with 3 variables. But in here for now, since we don't have that bias voltage, so there's only 2, the diode and then the voltage input. Okay. All right. So let's have an example for you guys to appreciate this one. Before, well, anyway, before anything else, do you guys have a question so far?
None, sir.
So,
None, sir.
all right. So if you have a question, please, okay, ask right away so that we can deal with it as soon as possible. Okay, so that you don't get confused in this part or in that part, and it's you don't have to be shy. So just ask, please. Okay. So for this one, it is only asking us to solve for voltage output. Well, actually, for the clippers and clampers, all that is it is asking is the V sub O only. Okay, no more other variables. Okay, we just deal with voltage output of this certain circuit. Okay, so for the positive half cycle, as you can see, if this one is ideal, this one will become reverse bias since this one is connected or the N type is connected to the positive side of the power supply and then the N type is connected to the ground. So as a result, this one will become reverse bias. Okay, so of course, since it's in reverse bias, it will not allow uh, to conduct a current. Okay, so 0 volts. And then for the negative half cycle, okay, so now our negative or our N type is connected to the negative side or the ground, and then the P type is connected to the positive. So this diode now will conduct a current, okay, or it will now allow to pass through a current. So as a result, this diode will become forward bias. Okay, so if it's forward bias, so we have to deal now with the voltage threshold of this one. Okay, so as you can see, V sub I plus V sub D. But since this diode is in ideal, so we have to put here 0. Then of course we have to consider the sign since we are in negative. So this one will become negative 5 plus 0. So as a result, our voltage output on this one is negative 5 volts. All right. Did you guys get it so far? So this is the same with the half-wave rectifier last meeting. It's just that it didn't indicate that this one is series positive clipper. Are we clear so far regarding with our example number 1?
Yes, sir.
Yes, sir.
Yes,
All right,
sir.
so very simple, very basic. Okay, so moving on, let's have another example wherein we now have to make it non-ideal. So when we say non-ideal, so our diode now has a voltage threshold. Okay, same idea or same question. So solve for V sub O. So we have here the solution for the positive half cycle. So as you can see, nothing changed. Okay, this one is still, oops, correction. Okay, so this one should be, the opposite, the other way around, because we are still in positive half cycle. So positive, okay, so let me just write this one. So I can change this one later on. Slide. 10. All right. So again, correction. This one should be the other way around. So the positive side is on this one, and then the negative side or the ground is on this one. Okay. So positive to negative, and then negative to positive. So as a result, this diode will become reverse bias. So if it's reverse bias, it will become open circuit, and then thus will not accept voltage, okay, or a current. So as a result, of course, we're having a voltage output of 0 volts. And then for the what is it? Solution during the positive. Wait. So there's a lot of corrections. Anyway. So for this one, the correction is you have to flip the voltage source. Okay, slide number 10. Okay, positive and then negative. And then for this one, solution during the negative half cycle. Sorry for that one. Slide 11. So again, correction. For the slide number 11, this one should be negative. So solution during the negative half cycle. All right, so I think instead of using the PDF, I'll be using the PowerPoint so we can edit the, the corrections right away as soon as possible. So let me just close this one. So for the slide number 10, well, I cannot do that one now. For this one, I can change this one now. Negative. There you go. All right. So for the slide number 10, so before this one is positive, so right now this one is negative. So in negative half cycle, so as you can see right here, we have here the negative side connected to the N-type, and then the positive side is connected to the P-type of the diode. So as a result, this diode will become what? Are you guys still there?
Forward bias, sir.
So this one will become forward bias. Okay, so if this one is forward bias, then it allows to pass through a current. So as a result, we have to deal with the voltage output. So what is our voltage output? So the formula for that one is V sub I plus V sub D. So our voltage input is -5 plus 0.7 volts. Okay, so as a result, our voltage output is now -4.3 volts. Okay, so during the positive, we have 0 volts, and then during the negative, we have -4.3 volts. Okay, and then here's the waveform, approximated waveform of the example number 2. Okay, 0 and then -4.2. Right? So let's say we're now done with series positive clipper without bias. So let's now deal with bias. Okay. So what is this with bias? So to say with bias, then there's an additional applied voltage in that circuit. Okay. So we do this one with bias because sometimes it is desired to remove a small portion of positive half cycle of the signal voltage. Okay. So for this purpose, a bias clipper is used in the future under clipper is used in the figure on the right, shows the circuit of bias series positive clipper. Okay, so we have two scenarios here. We have the positive bias and then the negative bias. So what is this positive bias? So it's just the polarity of our bias voltage. So as you can see right here in positive bias, the positive side is on this side and then the negative side is on the bottom one. And then of course, vice versa for the negative bias. The negative bias is like this. So negative side is on this one and then the positive side is on this side. Okay. So those are the only things that you need to know when it comes to series positive clipper with bias. So depending now the polarity or with the polarity of your bias voltage, it could be positive bias or it could be negative bias. All right, so without a further delay, let's now go to the concept or the characteristics of this series positive clipper with positive bias. Okay, so as you can see right here, if we are in positive half cycle, positive is connected to the N type, and then N type, a P type is connected to the N type, wherein as a result, this one will become a reverse bias. Okay, so if that is the case, so what about the bias voltage? So if I were to draw this one, I think I have to show you the step-by-step figure. So we have here the V sub I, and then we have here the diode. Positive, oops, eraser. Positive, negative. All right. So if we are in positive half cycle, so our polarity of our voltage input is positive and then negative right here. Okay. So if this one is positive and then negative, so as you can see, our diode now will become in reverse bias because our positive side is connected to the N type and then our negative side is connected to the N type. So as a result, this one will become what? Forward bias or reverse bias?
Reverse bias, sir.
So if this one is reverse bias, then you could say that this one now is in open circuit, right? So as a result, okay, oops, why is it lagging? So as a result, okay, our VI now will not conduct on this side. But how about our bias voltage? So where is our bias voltage? This one, okay? So before we have here the positive side and then the negative side. So as you can see right here, positive bias voltage is connected to the P type of our diode and then the negative is connected to the N type. So as a result, this bias voltage will make this diode a forward bias. So V sub I is in reverse bias. And then bias voltage is in forward bias. Okay, so meaning if our VB, okay, is higher than our VI, okay, then it will conduct at that point, at that certain point. Okay. However, if our, if our VB is always lesser than our VI, then we'll never be able to conduct a current on that circuit. Okay. So the only time that our VB will be able to make this forward bias if VB is greater than VI. So as you can see right here, if ever that our VB, okay, if ever that VB is higher than VI, so we could say that it is only open circuit for the V sub I, and then for V sub B, which is our bias voltage, it is conducting a current. So we could say that V sub O is equal to V sub B minus V sub B. So y minus v sub b, since of course we have to deduct the voltage in here. Okay, so as you can see, if this one is silicon, then we have to deduct 0.7. If this one is negative, if this one is germanium, then we have to deduct 0.3. Okay, so that is the computation for the V sub O in positive half cycle, right? And then for negative half cycle, okay, if, so this is too hard. I hope I have a blackboard and whiteboard. I think that I can draw it. Anyway, so maybe I will buy soon I don't know what you call that one, sketch pad or sketch tablet. So I can have an easier way of, showing a graph or a solution. Anyway, so for the negative half cycle, as you can see right here, if this one is negative and then this one is positive, so negative is connected to the negative side and then positive is connected to the positive side. So as a result, this diode will become a forward bias. So the same with this bias voltage. Positive is connected to the positive side and then negative is connected to the negative side. So our V sub I is in forward bias and then our V sub B, which is a bias voltage, is also in forward bias. So as a result, all of our voltages will conduct. Okay. So now this one will become a closed circuit. Then we just have to deal with this, the polarities of our voltages. So to compute for the V sub O, so V sub I plus V sub D, okay, plus V sub B. So we now have to deal with those two components instead of having the V sub I. Okay, so one for the voltage threshold and then one for the bias voltage. Okay, so for you guys to appreciate this one, we have here an example. So example number 3, so series positive clipper with positive bias, wherein we're dealing with the diode which is ideal. So solve for V sub O. So during the positive half cycle, as you can see right here, our V sub I will not conduct. But for our V sub B, it will conduct since this one is in forward bias. Okay, so if that is the case, then V sub B minus V sub B is equal to 2 minus 0. Okay, so why is that 2 minus 0? Since as you can see right here, if this one is conducting, okay, then it will go right away to through our V sub O. Okay, so sorry for that one. I have to retrieve what I've said a while ago. So in series positive clipper, so it is the other way around, since our V sub B will travel to the nearest path of our V sub O. So as you can see right here, as our V sub B conducts, it will now also pass through this V sub O. Wherein I said a while ago that if our VI or if our V sub B is greater than VI, then that's the only time that our V sub B will conduct. But in this one, no. Okay. So even though our V sub B is lesser than V sub I or V sub 1, it will still conduct because, as you can see right here, our V sub B is closer with V sub O. So as you can see, as it conducts, it will now also pass through to our BO. Okay. So as a result, so we only have to deal with this ideal diode and then, the voltage or the bias voltage itself. Okay. So 2 minus 0. So 0 because our diode is in ideal. Okay. So we don't have to deal with the diode threshold voltage. So as a result, for the positive half cycle, we have here 2 volts. Okay. And then for the negative half cycle, okay, so our V sub I now will become forward bias, and then our V sub B will now be also in forward bias. So as a result, so we have to deal with everything, okay, just depending on the polarity. So V sub I is negative 5 plus V sub B, which is still 0 since our diode is in ideal mode, and then V sub B is negative 2. Okay, so as a result, negative 5 plus 0 plus negative 2 is equal to negative 7. So if you're going to take a look on this one, we have positive 2 on the positive half cycle, and then negative 7 on the negative half cycle. Okay, so there's only a portion that is, cut or limited or prevent on our positive half cycle. So it is still conducting, which is, just 2 volts. And then for the other side is, instead of having just the initial voltage, there's an additional, bias voltage. So as a result, this one now will become negative 7 volts. Okay, so positive 2, negative 7. All right, so for now, we will stop here. We will just continue the rest later on the part 2, since we now only have, I think, 30 seconds. So if you guys have a question, so we will answer that one, or we will deal with it on the part 2. Okay, so just reserve it for now. So yeah, that's it for now. So just see you guys on the part 2. So you guys may now leave. Just wait 5 to 7 minutes.